All right, everybody, so here we're going to do our notes over dilations. Just remember, dilations means that you're the same shape, you're getting bigger, you're getting smaller, you may even stay the same size, but you'll always be the same shape. All right, so here we go. A dilation is a transformation that produces an image that is the same shape to the original shape. I have a typo there. A dilation enlarges or shrinks the size of the original figure. Generally, the description of a dilation includes the scale factor or ratio. Please keep in mind that these two words, scale factor and ratio here, the two words here are going to be interchangeable. So they may say the ratio, they may say the scale factor, just like before. And most always, the center will be about the dilation, will be about the origin, okay? Sometimes we'll dilate about the actual vertex of a shape, and we'll get to some of those. Please remember that just like when we did similar figures, all the angles have to be the same, and your sides have to be proportional. All right. If the scale factor is greater than 1, then the image will get bigger. If the scale factor is between 0 and 1, and if you think about it, that's because you have a fraction. Okay, so if you have a fraction, then you're going to be getting smaller. And it is possible that your scale factor is 1, therefore you will have two congruent figures. All right, so now let's get to this. All right, so we're going to do some dilations about the origin, and it's super, super easy. Your scale factor is going to be noted with the letter K. So then you have capital D, little k, that means a dilation with a scale factor of K. These are your two original points. Your new points, just multiply them by the scale factor. Super easy. All right, so what you're going to do is you're going to go through and you're going to find all the points. So we're going to find W, X, Y, and Z. So W is located at -1, 4. X is located at 0, 1. Y is located at 5, 1. And Z is located at 4, 4. So what we're going to do is we're dilating about the origin, and our scale factor is 2, which means K is 2. So all you have to do is multiply every single number by 2, and you'll have your W prime. So -1 times 2 is -2. 4 times 2 is 8. So this would be -1 times 2, comma, 4 times 2, comma. So that's how you do it. So X prime would be 0, 2. Y prime, 5 times 2 is 10. 1 times 2 is 2. And Z prime would be 8, 8. So when you plot this, you go -2, 8. So this would be W prime. 0, 2. So X prime would be here. So 10, 2. So this would be your Y prime. And 8, 8. This would be your Z prime. And then you would connect all your dots. So you have your new parallelogram. And it is similar to the original. So there you go. All right, so let's try it again. This time we're going to have a scale factor of 1/2. So this time our K is 1/2, and we're still dilating about the origin. So we need to find the points X, Y, and Z. X is located at 6, 6. Y is located at 2, 0. And Z is located at 8, 2. This time our scale factor is 1/2, so we're just going to multiply everything by 1/2. For example, 6 times 1/2 is 3, so this would also be 3. 1/2 of 2 is 1. 1/2 of 0 is still 0. 1/2 of 8 is 4, and 1/2 of 2 is 1. So now here's your new points. So 3, 3. So this should be getting smaller. So X prime, 1, 0. That's going to be our Y prime. And 4, 1, 2, 3, 4, 1. So there's our Z prime. And then connect your dots, and I'll just use this one since it's closer together. It's smaller, but it's going to be ugly. All right, so there's your new one. And here are your new points. Now, what happens when we dilate and it's not the origin. Okay, this is the exact same picture from a while ago, so we have the same W, X, Y, Z. So let's just rewrite those points down. We already know them from the other one. And it's just as easy, it's just different. Okay, so here are our points. Now, to find W prime, X prime, Y prime, and Z prime. Okay, first of all, our scale factor is still 2, so K is still 2. This time we're going to dilate and we're going to use Z as our center. So that means this point right here will not change. So it's still going to be 4, 4. Now, you have to use distance and slope. So basically what you're going to do is you're thinking, okay, how long is it from W to Z? So there's 1, 2, 3, 4, 5. So since WZ is 5, that means W prime Z needs to be 10 because 5 times 2 is 10. So I've already, starting at Z, you go 5, 6, 7, 8, 9, 10. So here is W prime. So this is negative 1, 2, 3, 4, 5, 6. So negative 6 is how many I went over, and 1, 2, 3, 4 is what I went up. So there's where W prime is. So now here's one side to my new parallelogram. Now, notice from W to Z, you got to go down 3 and over 1. So if I go down 3 and over 1, I need to double both of those numbers because my K is 2. So 3 times 2 is 6. 1 times 2 is 2. So from this point, we're going to go down 6. 1, 2, 3, 4, 5, 6 over 2. And there's where my X prime goes. So that's 1, 2, 3, 4, 1, 2. So I go down 4 and down 2. So now here's the line segment for that one. Now since this is also 5, then I need to double it. Starting from here to here is 5. So from here over, I need to go 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here should be my Y prime. And then I connect those two. Connect those two. And there is your figure. It's still 2 times bigger, but it is dilated about point Z. So Y is at 1, 2, 3, 4, 5, 6, 1, 2. Over 6, down 2. And that's all you got to do. So you just use your slope and you use your actual length and your scale factor. So same concept, little different steps. So now let's try it again. This time our K is 1/2, and we're going to use X as our center. So X, Y, and Z, they're the same X, Y, and Z from the other triangle. So this is 6, 6. Y is at 2, 0, and Z is at 8, 2. So since X is our center, X stays the same. And we're going to go from X to Y. I've got to go 1, 2, 3, 4, 5, 6. So I got to go down 6, and then I got to go over 1, 2, 3, 4, and I got to go over 4. Well, since my scale factor is half, I'm going to take half of both of these numbers. So that means go down 3, go backwards 2. So from this, I'm going to go down 1, 2, 3, backwards 2, 1, 2. So this is where my new Y prime is. So Y prime is at 1, 2, 3, 4, 1, 2, 3, 4, 3. And do the same thing for XC. So if I go 1, 2, 3, 4, down 4 over 2. So if I go down 4 over 2, half of that is down 2 over 1. So from here I'm going to go down 2 over 1. There's my Z prime. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 7, 4. So that is how you do a scale factor dilation about an actual point. All right. Now, What about composites? Okay, remember that's when you do two or more. All right, so this one says that Sarah has to make changes to a blueprint for landscaping in her backyard. Below is a picture of her backyard with a triangular garden labeled A, B, C. She needs to translate the garden, so we're going to slide it. Then we're going to reflect it over the y-axis. So this is where those knowing your rules come in handy. So first thing we're going to do is we're going to find point A, which is located at 6, 4. B is located at 5, negative 4. And C is located at 1, negative 3. The first thing I need to do is translate. So I'm going to add 2 to all of my x's. So that's going to be 8, 7, and 3. And then it says to subtract 5 from all the y's. So 4 minus 5 is negative 1. Negative 4 minus 5 is negative 9. And negative 3 minus 5 is negative 8. Then I'm going to reflect it over the y-axis. And this will give me my double prime, which is my final answer. So remember the rule when you reflect over the y-axis is that your y value will stay the same. So negative 1, negative 9, and negative 8. Negative 1, negative 9, and negative 8. And then your x values will simply change signs. And that's just the rule, nothing to it. And this would be your final answer. Okay, example 2. The point K is located at 3, 4. So K is located at 3, negative 4. It says it's rotated about the origin and then dilated. So I need to rotate it 90 degrees and then dilate it by a scale factor of 2. So K prime, and this is going to give us, this should be a double prime here. So if I rotate it, remember the rule for rotating 90 degrees is to do what? Rotating 90 degrees. So you have your X and your Y, and when you rotate 90 degrees, they trade places, and the Y changes symbols. So when we rotate 90, they trade places, and then Y changes sign. So they trade places, negative 4, 3, and then you change the sign of the Y. So 4, 3. So first I'm going to go 1, 2, 3, 1, 2, 3, 4. Oops, that's not it. Right here is my point K. So K prime is located at 1, 2, 3, 4, 1, 2, 3. So this would be K prime. But K double prime is the reflection, or no, the scale factor of 2. So all you're going to do is multiply both of those numbers by 2, giving you 8, 6. So 4, 5, 6, 7, 8, 3, 4, 5, 6. So this would be your K double prime. That's where I want to know where I'm at. All right. Now what if we take this trapezoid and we rotate it 90 degrees about the origin after we translate the trapezoid 1 unit down and 2 units to the left. So I need to translate, so X 2 units to the left, that's your X values. 1 unit down is your Y values. So I'm going to translate it, then I'm going to rotate it. So let's give these some points, R, S, T, and U. So R, S, T, and U. So R is located at negative 7, 3. S is located at negative 6, 6. T is located at negative 2, 6. And point U is located at negative 1, 3. So we're going to translate first. So R prime, S prime, T prime, and U prime. So subtract 2 from each one of your X values. So negative 7 minus 2 is negative 9. Negative 6 minus 2 is negative 8. Negative 2 minus 2 is negative 4. Negative 1 minus 2 is negative 3. And then the Y values, I'm going to subtract 1 from each one. So 3 minus 1, 6 minus 1, 6 minus 1, 3 minus 1. Now, I'm going to rotate it 90 degrees. So remember, rotating 90 degrees, the points trade places, and then you change the sign of the Y. So my final answer should be, let's go over here, R double prime. So they trade places. So 2, negative 9, and then change the sign of this one. S prime, double prime, is 5, negative 8. They trade places. Change the sign. T double prime, they trade places. Change the sign. And U double prime, they trade places. And change the sign of the X. So this would be your final answer over here. All right. And the last one is, how do you go from here to here? Well, what if you're already given the points? So for example, H is located at negative 6, 3, and we're going to go to H prime, which is located at 4, negative 2. So what I'm going to have to do is play with my answer choices and see if it gets me where I need to be. So let's try subtracting the 2 from x. So negative 6 minus 2 would give me negative 8. 3 plus 1 would give me 4. And then if I reflect it over the x-axis, the x stays the same and the y changes, which isn't where I need to be. What if I added 2 to the x? So negative 6 plus 2 would be negative 4. 3 minus 1 would be 2. Then reflect over the y-axis, which means the x changes signs and the y stays the same. Still not what I need, but a little bit closer. Well, what if I rotate 180 degrees? Well, remember when you rotate 180 degrees, they both just change signs. So from x to y, when you rotate, becomes negative x, negative y. So if I take this and change my signs, negative 6, 3 would be 6, negative 3. And then dilate by a scale factor of 2/3. So 6 times 2/3 would be 2 times 6 is 12. 12 divided by 3 is 4. So my new x value is 4. Then do the same thing with the 3. 2/3 of 3. Well, 2 times 3 is 6. 6 divided by 3 is 2. But it was negative, so we have that negative there. So now I've got negative 2. Well, that's what I need, so that's my answer. All right, guys, have a great weekend, and I will see you next week.